Hello learners, I welcome you all for an effective learning about the reference architecture of the data warehouse in this module. A reference structure in the area of software program architecture or organization structure gives a template answer for an architecture for a particular domain. It offers you a common understanding of the names and layers. In this picture, you can compare and contrast between two different things, that is a single data warehouse and a multi-data warehouse. Before explaining the components, let us first see what is CDW. CDW means Core Data Warehouse. It is also known as Enterprise Data Warehouse. There are two sorts of data warehouse architectures that we will see and suggest to customers. First one is a single data warehouse. A single data warehouse solely has one organization vast statistics mart on top of the CDW. It applies to only one organization. On the other hand, a multi-mart data warehouse has more than one data mart on top of the CDW. This plan we normally see at surely large clients, and the place it doesn't make any feel to push all the statistics only in one single data mart. An exact example is a separated data mart for international monetary reporting, one used for production analytics and another one for providing chain optimization. Now let us see how many layers are there and what is the purpose of each layer. First of all, every layer described in a data warehouse architecture ought to have a positive reason to be there. The definition of layers is a conscious selection of the data warehouse architect, and no layer is just there by way of accident. So now let us see the layers and the purpose of every layer. First layer is the staging layer. The staging layer helps a 1:1 reproduction of supply system extraction. The most important aim is to convey the facts as quick and as easy and viable from the sources to the SQL server. Additionally, in order to reduce the supply system interaction. Data in the staging location is transient or semi-temporary and can be deleted after all information is loaded into the CDW and the archive. The second one is the staging area design principles. This picture gives you a brief overview of how the design principles are applied. Let us see what are all the planned rules that are followed for the staging area. The first rule is 1:1 copy of the source system. The next one is same name meaning conventions. That is, same conventions should be followed for naming and data types as the source system. No transformations need to be applied, no aggregations and no fine checks. Next we can see what is the stage location per source system. The first 5 concepts which we saw now centers around the concept of bringing the information as convenient and as fast as possible into the staging layer of the data warehouse in order to reap clean connectivity to our sources. We additionally prefer to preserve the extraction workload as brief as possible in order to minimize the load of outsourcing systems. An enterprise resource planning system like the SAP ERP is normally mission vital in a client-employer surroundings. So, we favor to limit the statistics extraction that will affect on the day-by-day business. Therefore, we continually prefer for a delta extraction process if the source system is in a position to deliver modifications only. The factor of having one staging area per source device is because of workload and record separation. This design relies upon a little bit on the flavor of the architect and also on the different numbers and complexities of the supply systems. Of course, it is additionally viable to separate source system in the staging area through defining specific schemas per source gadget in large corporation environments, and a committed database per supply is a greater common. Staging area will follow a SSIS loading pattern because we have no additional logic to implement at some point of facts supply extraction. The SSIS application looks very simple. This picture gives a brief overview of the steps in the SSIS interaction. We use a source machine adapter, the one that suits fantastic for the unique source system connectivity. In this case, an OLEDB source. Extract the data and some audit data like create date or load ID inside a derived column task and store the data in our staging table. This appears very easy, isn't it? And exactly this was once the intention for staging area information loads. Now let us see what is an archive. The archive layer is our life insurance. Why do we call it so? Because it maintains the full data history. The data warehouse has to track the complete history. That capability that every single attribute trait would have been tracked in the CDW layer. Of course, this is very expensive, particularly if only for around 10% of the attribute records tracking is of interest for business person analysis. So, why to track 100% in the CDW and no person uses it? Does it make sense? I assume no. However, in order to be flexible, because we don't be aware of which attribute history is of interest in the future. So, we need to track the full records in our archive. We cannot just do a 10% or 20%. We have to do it the full 100%. Now, let us see the main purpose of an archive. So, the archive is what is about the data history first. This will give you an idea about what is data history, and there are two sorts of records tracking in a data warehouse. One is the fact data changes, and the fact data changes is the easy one because every reality report has a link to a sure point in time our facts or records tracked automatically. The second one is master data changes. This is the difficult one and is additionally comprehend as slowly changing dimensions, that is SCD. In this case, we track attribute changes in our dimension like telephone number or address information. When we say we recommend no longer to track the full records inside the data warehouse, we mean now not to track simply in advance all the attribute adjustments that manifest simply. Based on my journey, solely 10% of history tracked dimension attributes are used with the aid of enterprise users. So, why I then track the extra 90% if no person uses them? This is an interesting question. But do you genuinely prefer to pay the rate for that? And the charge would be lot of between joins in your data warehouse and between joins or very fee sizable operations. We will dig into that subject in that we will submit about the CDW design. To make it short, we have the full records, fact and the master data in our archive and are always able to create a new SCD2 table in our core data warehouse whenever needed. So, the summary is instead of storing a 10% or 20%, we will be storing the entire 100%. Next, we will see the design principles followed in an archive. This picture is just a summary of the principles which are used. The archive follows the same design rule as the scaffolding field plus some additional principles. One is the 1:1 copy of the staging area, same naming conventions and data type as the staging field, no transformation, no assembling, no quality checks, and one archive per staging area. Use compression and partitioning. Apply delta detection if necessary. These are the design principles which are used in designing an archive. If the reference systems are not able to deliver data changes only and instead give you a full extract of their data, every clip I would add some logic before loading that data to the archive. In case of full exception, your archive will grow very rapidly. So you need to add the delta detection logic between staging and archive and loading only the data changes into the archive, not all the data. I also would apply tabular array compression and partition. Partitioning in case you need to load a certain extract again from the archive to your data warehouse. Now we will see the archive SSIS loading pattern. Because we have no further logic to implement during the SSIS software looks very simple. From the staging table it moves to the audit info, and from the audit info it will move to the archive table as depicted in this picture. We use a OLEDB adapter to attach to a staging data, extract the information, add some audit data like create date or load ID inside the derived column task, and store the info in our archive table. Again, a simple and straightforward approach. Having looked into that, now we will see what is the functioning of the CDW. This layer is the relative information warehouse layer, and since it is used for business analysis, its modules as star schema. However, an extra terribly import purpose of this layer is quick ETL. What will that mean? If the analysis requires obtaining more durable info and you wish to optimize the info model for reportage, for example, for aggregation, indexes and many other tasks, so as to meet business user necessities, you wish to push it to the info sales outlet. Otherwise, your whole ETL method would suffer from performance and optimize a layer for each. That is for ETL and reporting. And it may be a very hard job. The CDW isn't designed as a mixture of all information marks. The main goal of the CDW is to represent the full enterprise of a client at rock bottom roughness if possible. Now let us see a comparison of data mart and the centralized data warehouse with the use cases. There are several use cases that highlight with an example of when to use each approach to data warehousing. So the data mart use case will be the example for several scenarios. One is the market analysis. The market analysis and reporting favor a data mart approach because these activities are typically performed in a specialized business unit and they do not require an enterprise-wide data. Another scenario we can see is a financial analyst who can use a finance data mart to carry out financial reporting. Now let us see what is a centralized data warehouse use case. We need to understand this clearly before designing a warehouse. For example, a company considering an expansion needs to incorporate data from a variety of data sources across the administration to come to an informed decision. And this requires a data warehouse that aggregates the data from various departments like sales, selling, computer store, direction, customer loyalty, supply chain and many more. Many factors private road profitableness at an insurance company. An insurance company reporting on its gain needs a centralized data warehouse to combine entropy from its claim department, sales department, customer demographics, investments and other domains. There are several examples which we could have for this. Next we can see how to design the data mart and the function. The data mart is designed as an optional layer above the CDW. The data mart data model is also designed as a star schema. We need to look into this very carefully, but there needs to be a certain intellect to have an additional star schema on top of the CDW. And what can this be? There are many things. One is aggregation, dimension, history usage, business logic, and strong requirements for relational reporting. As we have seen already, it is said that if the requirements for relational reporting are hard to use. Now let us see a comparison of data mart and a data warehouse. A information mart is a subset of a data warehouse oriented to a specific business line and not the entire data. Data marts contain repositories of summarized data collected for analysis on a specific department or unit within the organization. For example, the sales department. We need to remember that it is for a specific task. On the other hand, a data warehouse is a large centralized repository of data that contains information from many sources within the organization. And the collated data is used to guide business decisions through analysis, reporting, and data mining tools. In this picture, we can have an overview of the steps involved in the transaction of data from one stage to the other. And let us see how the data mart and the data warehouse could be compared. The focus of a data mart is a single subject or functional organization area. And the sources from which the data mart will get data are relatively few sources. And these sources are linked to one line of business. And the size would be less than 100 GB. And if we look into the normalization, no preference between a normalized and denormalized structure. And the decision types that will be made in a data mart are tactical decisions pertaining to particular business lines and ways of doing things. And we should know about the cost of the data mart also. It typically ranges from $10,000 upwards. And the time taken to set up such a data mart is 3 to 6 months. And the data held in such a data mart will be typically summarized data. Having seen what is a data mart, now we will see the focus of a data warehouse. The focus of a data warehouse is enterprise-wide repository of disparate data sources. That is, we will be getting data from all the departments, storing the complete data. So, where does the source come from? Many external and internal sources from different areas of the organization are used to take the data into the warehouse. And naturally, the size will also increase when we get data from many departments. So, the size will be 100 GB minimum, but often in the range of terabytes for large organizations. And if we think about whether we need normalization, modern data warehouses are mostly denormalized for quicker data querying and read performance. So, as we need more storage, naturally the cost will also go high. The cost will vary, but often greater than $100,000. And for cloud solution, the cost can be dramatically lower as organizations pay per use and they don't pay for all the uses. In that way, the cost is reduced. Now, let us know about the setup time for such a data warehouse. At least 1 year for on-premise warehouse and a cloud data warehouse are much quicker to set up. So, the cloud data warehouse setup is minimal work compared to on-site data warehouse. And the data held in such warehouses are raw data, metadata and summary data. And we need to know what is a multidimensional data mart also. The multidimensional layer typically implemented with analysis services, it is also an optional layer on top of the relational data mart or the CDW. We need to know which technology to use in case of reporting. Depends always on the business layer and the user reporting requirements. Having seen a comparison about the data mart and the warehouse, we will get into what is an ETL process. ETL process means extract, transform and load. And this is an automated mental process which takes place within the data warehouse. So, where does it take place? It happens to be a raw data formation and extracting the data required for analytic thinking, and it also transforms it into a format that can serve the business needs. And after loading and extracting and transformation, it will load the data into the data warehouse. This is how the ETL works. Naturally, the ETL typically summarizes the data to reduce its size from its bigger size to a lower size, and thereby it is improving the performance for particular type of analysis. When you build an ETL substructure, you must integrate the data sources and you have to carefully plan and test to ensure your transformation of the source data correctly. Because if the transformation goes wrong, whatever decisions made will be a problem. Now we will see the three senses of way to perform an ETL infrastructure and one more way to build a data pipeline without using ETL at all. So in this diagram you can see how the data is being extracted from the database and loaded into the warehouse, where it is being transformed and then loaded, and then after transformation the analysis happens. So let us see the two ways to build an ETL process. The first step is you have to build an ETL pipeline with batch processing. After building the pipeline without ETL, use an automated cloud-based data warehouse. Now we will see how to build an ETL pipeline with batch processing. There are several methods. Now we will see how to do with the batch processing. Following the process given in the picture to build a traditional ETL process in which you transport and process the information in batches from the source to the data warehouse. So we are not importing one by one, rather we are importing in batches. Hence it is challenging to build an enterprise ETL pipeline from scratch. And you will typically rely on ETL creation such as Stitch or Blendo, which simplify and automate much of the process. We can make use of these tools to simplify the process. Now we need to know about the reference data also. The reference data creates a lot of data and that will define the set of permissible values your data may contain. For example, in a country data field, you can define the list of country computer code that is allowed to be stored there. Next, we will see how to extract from the data source. Now that we have taken the data, we need to know how to extract it. The basis for the success of subsequent ETL steps is to do the selection of data correctly. Suppose if we go wrong in the data selection, the final processes will lead in a wrong result. So you need to take into account that the correct data is being selected. Most ETL combine data from multiple source schemes and each with its own data organization and data format, including relational databases and non-relational databases, and also XML, JSON, CSV file cabinet and many more formats. What we mean to say here is that the data which we are extracting will be of various types and we need to be careful about that. Successful origin convert data into a single format for standardized processing is very much necessary when you are really dealing with different data types as we have seen earlier, since the same method cannot be used for different types of data. And after we have extracted the data, we need to validate the data. So what is validation? Let us see. It is an automated process and it will confirm whether data pulled from root has the expected values to check whether we have taken the correct value. Let us see an example. In a database of financial transactions from the past year, a date field should contain valid particular date within the past 12 months. If it doesn't contain a valid date, then the data we have extracted will be of no use. And the validation will reject the data if it fails the validation rule. And you can analyze the rejected records on an ongoing basis to identify what went wrong and how to correct the source data or how to modify the extraction. And this will resolve the problem in the next batches. And after you have done validation, now assume that we have the correct data. Now with the correct data, what we have to do is transforming the data. So let us see what is transforming the data. Transforming the data means removing the extraneous or erroneous data. That is, we are cleaning up the unwanted information by applying concerned rules and by checking the data integrity. You need to ensure that the data was not corrupted in the source or corrupted by the ETL and that there was no data that was dropped in previous stages. This we need to be very careful that I remove only the unwanted data and I retain the correct data. And later I can create aggregates as necessary depending on the group of data that is existing. You can summarize the dollar amount of bill into a daily or monthly total. For example, if you must analyze tax revenue, you can summarize the dollar amount of the bill into a daily or monthly total. In this way, we can create the aggregates. And you will need to program and examine a series of rules that can be used and that can be achieved through the required transformation, and then run them on the extracted data. Having seen how to transform the data, let us see how to build a pipeline without the ETL and using an automated cloud-based data warehouse. Everything is cloud nowadays, and new cloud-based information warehouse technology makes it possible to achieve the original goal of a ETL. How does it achieve is, it achieves that without building an ETL system at all. Let us see an example. For example, Panoply's cloud-based automated information warehouse has close end-to-end information direction anatomy. It uses a self-optimizing architecture with machine learning and natural language processing, and there are several other algorithms also. And these techniques are used to automatically extract and transform the information to match the analytics demand. And Panoply has its own advantages. It comes pre-integrated with dozens of data sources that you can use, including data analytics system, the business intelligence tools, databases, mixture and advertising platforms. And hence, building a data pipeline without ETL in Panoply involves several steps. And as a user or a customer, you need to know the steps involved in the Panoply. The first step what you have to do is, you have to select your data source and import the data. And when you select your data source from a list, you have to enter certificate and define name and addressable tables. And click collect, and Panoply automatically will drag the data for you once you give the required details. Panoply automatically takes care of the outline, data homework, data cleaning and many more activities also. As you can see in this picture, the steps which we have mentioned, that is, you give the required information and then when you click, you will get all the data which you needed. And once you do that, then you can run the transformation queries, since you have the data selected for your use. And now we will see how to do that. You have to select a table and test a SQL query against the raw data formation. The query can be according to your request. That is, it can be to selection of customer, or it can be to deletion or addition of customers. You can save the query as a transformation, or you can export the resulting table into your own system. Either way we can do that. And Panoply supports both simple views and materialized transformation views. So you can have either way, in whichever way you want to generate a report. And you can run several transformations until you achieve a data format that enables depth psychology. Because with just one transformation, sometimes we may not be able to get the result. So we can apply multiple transformations according to our need. Now we will see the integration logarithm. A Panoply's integration logarithm will help you to easily coil back to previous processing at a stone's throw. Why we say at a stone's throw is, it is easy. And you shouldn't be concerned about running the data. Panoply lets you perform any transformation but keeps your raw data intact. Hope you have understood the importance of Panoply. That is, it will have the raw data carefully. At the same time, you can apply the transformation and you can get the results also. Now let us see how data analysis can be done with the business intelligence tool. You can now connect any business intelligence tool such as Tableau or Ravisher to Panoply and explore the transformed data. I hope you are following the steps. In the previous step in Panoply, we transformed the data and we have got the result, and now we are applying a business information tool. The above process is agile and flexible, allowing you to quickly load the data, transform it into a useful form and use it to perform business analysis. Now, having seen all the design principles and the tools which we can use here, let me give you a summary so that you can have an overview of what all things we have covered in this module. A multidimensional data warehouse is typically used for the design of corporate data warehouse and departmental data marts. and such a model can adopt a star schema or a snowflake schema or a fact constellation schema. On the other hand, a data warehouse is an information system that contains historical data and cumulative and commutative data from single or multiple sources. And we should also remember that a data warehouse is subject oriented as it offers information regarding subject instead of organization's ongoing operations. You also need to remember that in a data warehouse, integration means the establishment of a common unit of measure for all similar data from the different databases. Otherwise, the data in which we process will not yield the correct result. Hope you have got an overall idea of what is a data warehouse, data mart, the design principles. Happy learning. Thank you.